Okay, hi guys. For today's assignment, we are going to be doing example 5.8 from the textbook. In today's assignment, we are going to be weighing a fish in an elevator. So a person weighs a fish of mass m on a spring scale attached to the ceiling of an elevator illustrated in the figure in the textbook. I'm going to draw a simple illustration of that here. So for A, we are supposed to show that if the elevator accelerates either upwards or downwards, the spring scale gives a reading that is different from the weight of the fish. Okay, so essentially this is what we have. Excuse my fish, very pretty fish. So this is our tension, and this is our weight of the fish. So the tension is the number that the spring scale is going to read, or that's what it's going to show. Okay, so from here you can clearly see that for the summation of forces in the y direction, which is summation Fy, would be equal to the T, which is the tension, minus the weight. So we have this down. But we also know from Newton's second law that summation of F is equal to ma. So we can equate both these equations. So we have T minus mg equals to ma. You make T the subject here by taking mg to the other side. So T is equals to ma plus mg. So here we can take mg out of this equation. So T would then be equals to mg into, so you take mg out of ma, and then you have a out of g. Taking mg out of mg, that is just plus 1. So this is our equation 1. So here, what we are supposed to show is whether acceleration, when acceleration is upwards or downwards, it is still different from here. It can clearly be seen that if we have negative acceleration, our tension will be lesser than the weight here. And if acceleration is positive, our tension is going to be greater than our weight. So moving on to B. B says that if we have a 40.0 Newton fish and we have an acceleration of plus or minus 2 meters per second squared, what will be our tension? So we just use the first equation that we got from here to solve this question. So for positive acceleration, we have T equals to mg out of a over g plus 1. Now we need to find each of these variables. So we know that mg is the weight, which has been given to us already as 40. So mg is equals to 40 newtons. And then we have a. Our a has been given as 2 meters per second, and our g obviously from acceleration due to gravity is 9.8 meters per second. So here we have 40 out of our a, 2 out of 9.8 plus 1. So our tension with positive acceleration will be equal to 48.2 newtons. Okay, so moving on to negative acceleration. So for negative acceleration, we still use the same equation of T equals to mg into a out of g plus a. However, this time we have acceleration being negative 2. So T will be equals to 40, as I stated before. Our A is negative 2 out of 9.8 plus 1. So we have T being equals to 31.8 newtons. Okay, so for our last question in this example, it says that what if the woman steps off the elevator? When she stops off at the elevator and the cable breaks and the elevator free falls, what happens to the tension? Okay, so over here, when the elevator is in free fall, you can state that acceleration becomes negative gravity. And that is because now acceleration is moving downwards, which is in the negative y direction. And when an object is moving downwards, that would be acceleration due to gravity. That is why acceleration becomes negative gravity. And if you have, as we have t is equals to mg, like our previous equation, a out of g plus this. With this equation, if we have negative g, t becomes 0. Let me just show that out to you. So we have mg, and our a is now negative gravity. Gravity is 9.8, so minus 9.8 right now. So minus 9.8 out of 9.8 plus 1. So t is mg into minus 1 because of that plus 1. T is equal to mg times 0, which is 0. So it's clearly been proven now that if the elevator is free falling, acceleration becomes negative gravity, and because of that, our tension is 0. Thank you.